Let's look at a few key properties of the graph of an exponential function. So an exponential function is the form y equals a times b to the power of x is the type of function that we're thinking about. So a couple of things that will always be true. So no matter what, our domain for these functions is always going to be all real values. So these functions do not have any restrictions on the inputs. Your exponent can be positive, negative, fraction, decimal, anything is okay for that. Some other things that will also be true, if it's in this format without any type of shifting or anything like that, vertical shifting, then it will always have a horizontal asymptote. The horizontal line y equals 0, which is just our x-axis. It will also always have a vertical intercept at the point 0, a. So whatever that number is in front of the b to the power of x, that's always going to tell us where our vertical intercept is happening. So these things are going to be true for any exponential function that's in this form. So let's look at a couple of actual functions and see what is slightly different about these. So let's look at, for example, y equals 5 times 1/4 to the power of x. So one thing to notice here is that our value of b is less than 1. So the value of b will always be positive, but we'll be looking at whether it's less than 1 or greater than 1. So a couple of things that we can say for sure about this particular function. Its domain is all real values. Its range goes from 0 to infinity. It has a horizontal asymptote at y equals 0. It has a vertical intercept at 0, 5, and it has no horizontal intercept. If we were to sketch this graph, because the base is less than 1, we're going to see a function that is decreasing as it moves from left to right across the graph. And since it's got that range from 0 to infinity with a horizontal asymptote at y equals 0, it's going to stay above the horizontal axis, and so it won't have a horizontal intercept of any kind. The thing that makes it a decreasing function as it goes from left to right is that that base b is less than 1. So anytime your base b is less than 1, that's what we'll see. Looking at our graph, it's a little bit easier for us to think about end behavior using the graph. So we could say as x goes to negative infinity on this graph, so as we go to the left side of this graph, the function is going up forever, so it's going up to infinity. As x goes to positive infinity, so looking at the right side of our graph, this is where it's flattening out, and so our function is going to 0. So the left side is going up to positive infinity, the right side is flattening out. So now let's look at a different function. What if we had instead y equals 2 times 4 to the power of x? So this time our base b is greater than 1. Some things are still the same. Our domain here is still going to be all real values. Our range is still going to go from 0 to infinity. Our horizontal asymptote is still going to be y equals 0. Our vertical intercept is going to come from that 2 out in front, and there's still no horizontal intercept. Because our base b is greater than 1, this time we're going to see a function that's increasing as it moves from left to right across the graph. We still are going to have output values that are always positive, so it's going to stay above the x-axis as we're taking a look at this. That's where our range of 0 to infinity is coming from. So on this one, as x goes to negative infinity, this time that's where the function is flattening out and going to 0. And as x goes to positive infinity, the right side of our graph, our function is going up forever, so it's going to infinity. So both of these graphs have some features that are very similar. So what if we had a vertical shift of some kind? Is it possible to ever have a graph that has a horizontal asymptote and a horizontal intercept as well? So let's look at another function. What if we took that last function that we were just looking at, y equals 2 times 4 to the power of x, but what if it had a constant term at the end, a minus 3? So think about what this has done to our graph. This has caused us to shift down 3 units. So if you picture a sketch of what this graph would look like, the shape is still the same. But if you come down 3 units, everything is going to shift down 3 units, including that horizontal asymptote. So instead of having a y-intercept at 2, 0, 2, if we take that horizontal intercept at 0, 2, drop that down 3 units, we're still going to see a graph that's increasing as it goes from left to right, but everything has moved down 3. So think about what features have changed. The domain still is all real values, but the range has changed. Since everything moved down 3, now our range is going to go from -3 to infinity. We still have a horizontal asymptote, but it's moved down 3, so now it's at y equals -3. We still have a vertical intercept. It has moved down 3, so instead of being at 0, 2, it's now at 0, -1. It turns out that we now have a horizontal intercept. We can see it in the sketch of our graph that now it's crossing through. To find that, we would need to solve 2 times 4 to the power of x minus 3 equals 0. So adding 3, we'd have 2 times 4 to the power of x equals 3, and 4 to the power of x is equal to 3/2. So I could take the log of both sides of my equation here and use my exponent properties to move that x out in front. So x times the natural log of 4 is equal to the natural log of 3/2. So dividing this tells me that x equals the natural log of 3/2 divided by the natural log of 4. If we put that in our calculator, it's about 0.29. So that's telling us that there is a horizontal intercept. It's at the point about 0.29, 0. So it is possible for an exponential function to have a horizontal asymptote and a horizontal intercept, but only if it's had some kind of vertical shifting. So if it's in that form just a times b to the power of x, it will never have a horizontal intercept. But if we've had a vertical shift, it's possible that we could have both of those. The domain will always be all real values. The range can change if we have a vertical shift like we see in this one. We could also change the range if we had a vertical reflection. So if there was a negative out in front of our function, that would cause a vertical reflection, which would also change the range of our function.